Hey, welcome back. A little short break, make a nice clean break before the episode 3. So this is the third episode in season 2 of the MassTransit live coding videos. At the end of the last episode, we had created, a second state machine for the keeping track of reservations, and I was about to jump into, but I thought it'd be a good place to stop. How would we schedule a reservation? How do we add scheduling to the state machine? So I've done a lot of setup. It's all unit test based at this point. So I'm trying to keep it very focused on how do we build out the model before we jump into like API endpoints and all of that stuff. I'm really trying to focus this season all around the state machine and how we can take advantage of all the capabilities and how to do things with that. So, that's the key focus that I want to stick to here. Because it's something I get a ton of questions about. I mean, there's always going to be questions like, how do I configure an endpoint? But the state machine, it continues to come back of like, how do I do this? How do I test that? How do I build these capabilities? So that's really the key focus of these episodes. So again, so we're working on, the sample that we're working on is the sample library. It is available up on GitHub already. I did push the changes from episode 2 just a few minutes ago, so those are going to be online already. That way you can see the latest work that we did in episode 2. Episode 2 will be up on YouTube once I get it up there, as will this one once I upload it. I just decided not to upload it while I was trying to live stream at the same time. Gig fiber is great, but gig fiber has its limitations. So let's jump back in here. So the way we had left this off is we had created a reservation state machine. And here, let me close up a lot of this stuff here so we can just kind of focus on what we got here. So we have the reservation state machine. And it basically works the way is when we request a reservation, we get a book reserved and all is good. And that puts us in the reserved state. But one of the things that we want to do is we want to say, hey, you can reserve a book, but that reservation is only good for 24 hours. After 24 hours, that book is no longer going to be reserved, and it will be released so that someone else can get it. And there's 2 different things that we're going to have to keep track of in here. So let's start first by looking at how we create a scheduled item in the state machine. So the first thing I want to create is a message contract because, hey, it's all about the message contracts. And we're going to create a message called reservation expired. And this is going to include just something really simple, the reservation ID. That's all we need. There isn't anything else that needs to be in there because this is being scheduled back to the reservation state machine. So we will move this to reservation expired. And let's go back to our reservation state machine. We have to add this as an event. Let's put that in there as an event called reservation expired. And now we're going to create the schedule, which is going to take the reservation and the reservation expired event expiration schedule. Okay, so we have to define a property to store the schedule data in. In this case, it's schedule reservation expired, and we're just going to call it the expiration schedule so that we have it. We then have to come up here after we've declared our events. That's usually where I put it. And we defined the schedule. And we also have to configure it. When we create a scheduled item, that scheduled event has a token identifier, which is just another GUID with it. Because we may schedule it, but we may also want to cancel it. So we need to go back to our model for the reservation. And we're going to create a nullable property on here called expiration token ID. And this is where we're going to store that scheduled reservation token. And then we will come in here and specify the expiration token ID. And I think we have to specify one more thing. The delay, let's just say that the delay equals time span from hours, and let's just say it's 24 hours. So that'll let us define the schedule. And I think if we just run all our unit tests again, just to make sure that everything works, it'll tell us if there's a state machine configuration error, but I think that should work. There's something not set up right. Reservation expired was not specified. Oh, yep. So let's go back to our message contracts and add that to our list. At least the error messages are somewhat descriptive. Okay, so now our unit tests run, everything is great, so we're compiling again. Hold on, we have a question in the chat. I have a question regarding the reservation state moves to reserved. Should we still include the book and member since the correlation would take us back to the request event which contains the data? I'm not sure I understand the question. So when we get the book reserved event, yeah, I don't fully understand the question. The only thing that we care about out of that event for the reservation is the timestamp that the book was reserved so that we know when the reservation was accepted. I don't know that I completely understand the question. Maybe you can repost it in the chat with a little more detail, that'd be great. So now that we've created the schedule and defined it, we have to actually initiate it. So we're going to say is during requested, we're going to say when the book is reserved, we're going to transition to reserved, but we're also going to schedule the message for the expiration schedule. I'm trying to remember the syntax for this, which anybody is going to know. Context.init. What is it? What did I say? The reservation expired. And I'm going to pass context.data.id. Be fun. Okay. So this is going to let me use the schedule. And what I'm doing here is I'm scheduling this message to be sent with the default delay of 24 hours back to this state machine. Okay, so that's all we have to do to schedule the message. So at this point, we're going to be in reserved. So let's, I sure say so a lot, don't I? I've actually went back and looked at videos and laughed at how many times I say so in a session. So, just so you know. So during reserved, when reservation expired, so if the reservation expires, let's create a new state called expired. Not that we really care. If it expires, technically, we might do something fun like, sorry, your reservation expired, would you like to renew it? Or we would just finalize it and throw it away because it's no longer important. We have a couple of options there. We'll try both. So or we could just say when reservation expires, let's just finalize it. Let's just do that. Let's just say it's dead. And I'm actually going to put remove when finalized, set completed when finalized. And when we set completed, so previously before adding that statement, any Saga instances that were created would live forever. But now, because when a reservation is expiring, we're just going to finalize it. And I've gone in and put set completed when finalized. That's going to tell the repository to delete that instance. So when that reservation expires, we're just going to delete it and it's going to go away. That way we don't have to worry about it anymore. And we'll talk about some of the reasons why you may not want to do that or may want to do that later on. So when the reservation is expired, that's going to be sent directly to our state machine. But the book is still going to be reserved. So the question, is the saga deleted at that time? So the saga would be deleted at the end of processing the reservation expired message the way the code is written right now. So when finalize is there, all that is a shortcut for transition to finalized. And when set completed with finalized is there, it's going to, at the end of processing reserved, because it's in finalized, it's going to delete the saga instance. And we're going to do that for now, but we need to produce an event because we want to be able to tell the book to become available again. So this will get us to where we're finalized. And let's just check that first, because that's like the first thing we want to test as part of our unit test. So let's go to the reservation state machine specs. I'm going to copy this because I want to keep that test there because I'm obviously going to change this. Because we already know that works. When a reservation expires, should should mark book as available. I'm just going to put that for now. So we're going to do the same work we did before. We're going to add the book. We're going to create the reservation. We're going to put our hacky code in here that tells us that the thing exists, and I'm not going to over stress about that too much. I'm going to take these out because I don't care. I'm actually going to take this out too because I don't care at the moment. And this is just a cut and paste of our previous test, so it should work. Now that I have it in the reserved state, I'm going to know that that message was scheduled. And I'm just going to verify that this test runs real quick because right now it's not asserting anything new, so it should still pass. But now I'm going to put in here, I'm going to put advanced system time. I'm going to put time span dot from hours. $24. So I'm going to advance the times 24. Oh, and I have to await that because it's async. And so what this is going to do is that, remember in the base state machine test fixture, I've done some work to put quartz as part of the bus so that I have an in-memory scheduler, and I've set that up and I've captured the scheduler. Within my test little fixture class here I created, I have a method called advanced system time. And what this does is it puts the scheduler on standby, changes the test offset, and then restarts the scheduler. And the way the scheduler works is within this fixture, we've intercepted. So system time is a quartz class, and that is how quartz gets the current time. And by default, I'm just telling it to get UTC now, or to do datetime offset.utc now, because I believe it wants a datetime offset, yeah. I've created my own versions of that add an offset to the current time. And what this does is it allows me to turn the clock forward. So instead of like faking and saying, oh, well, let's just set the timeout to 1 second, we're able to actually test true business logic. And so what I want to do is I want to verify that 24 hours after a reservation was created, it gets expired and released. So this allows me to roll the clock forward 24 hours and then verify that that message was processed. Now, what I want to do is I want to come in and say, now because I'm finalizing, I have to do a different type of assertion. I have to await saga harness dot not exists reservation ID and assert is false, not exists dot has value. So I should not have a value here. I think that's how it works. I'm thinking backwards. That seems odd, but who knows? And what I want to verify here is that after I roll the time forward, does it actually delete that saga instance? And lo and behold, it does. Hey, it worked the first time. Clearly it must work, and I'm not thinking how it works. But let's just find out for sure. So you can see our receive happened. we got our book reserved, we went into the reservation state, we scheduled our message, reservation expired, and then you can see the scheduler was paused and the scheduler was started. So that's where we rolled the clock forward 24 hours. You can see the trigger executed, mass transit courts integration, scheduled job. That's just what it looks like when the scheduler sends a message, but it's sending it to the reservation queue. It's saying schedule was executed, so that trigger was run. The saga then uses that saga instance with that message reservation expired. It deletes, yeah, it's the scheduler deleting the trigger. You can see that we used and then removed that saga instance because again, we said finalize, and because we add set completed when finalized, completed sagas are removed from the saga repository. We then removed that instance once it expired. So that was pretty awesome, I think. We scheduled the message, we got the message, and we were able to remove that. Now we have to do a little bit more work though, because we also want to verify that the book is available. Because previously the book was reserved. And we actually didn't check that. We probably should. So let's go, when we created the reservation before we set up the time, we should actually check that the book is reserved. Because we never checked that before, that the book was not reserved. Here we go, reservation was not reserved. Make these messages a little cleaner. So now if I run this again, I should see that it should still pass because the book should be in that state. If it doesn't, that would be annoying. Book state harness, book reserved. I think this is that slow, not going to wait for it crash. So why does that not show up? We had it up here. Where's the first check? We checked to see if the book existed. Did I copy the wrong version? Why is that not there? Where my brain starts to hurt a little. I'm gonna try this one. Try them all. I'm gonna try everything. So the book saga harness dot created dot contain. I don't remember what the contains in state was. Oh, because it's the book machine. Dot sagas dot contains in state underscore book machine. That's where I think I've got something wrong with the type. Book saga harness, book contains in state. Book was not reserved. I'm never going to figure out how to spell reserved. It's going to drive me nuts. Why would this not work? So book harness sagas contains in state. So why did the book not go into the reserved state? Did we have the code actually run and put the book in the reserved state? We received the book reserved message, which was produced by the book state machine, and it transitioned to reserved. Why is it not in reserved? Plot thickens. Because we clearly saw it transition to reserved. So otherwise it wouldn't have sent it. We got the book added, book created, book used. We did the send of book reserved. Saga library, reservation. Used it. We finished the receive on the book. So we have to be in that state. That doesn't make any sense to me. Book ID. So with the book state machine, member ID, book ID, reservation ID, timestamp, book reserve, we're publishing it. It has to be there. Sorry, this is driving me a little bonkers here of why this isn't coming out this way, because the book should have been reserved. I don't understand why it isn't. Because if I take that out, it works. But do we see, because we see the whole flow. Oh, we don't see the flow because the book saga harness never goes back to available. We added that test. Okay, so let's not get too hung up on that because I want to move forward. I'll figure out that stuff later. I might have a 707 coming out tomorrow. We'll have to see. But I want to go to the book state machine and I want to add that other state in here. So during reserved, when, and I don't have a message for this. So if we remember, the event for the reservation expired is sent directly to the state machine by the schedule. So within the reservation state machine, which is keeping track of the timing, it has scheduled the expiration schedule to be sent back to itself. So this message is unicast. It's only going to this state machine. So when the reservation expires, we have to produce some type of event to let the book know that the book reservation was expired. And I think that I just said what I'm going to call the event is just like I have reservation expired, I'm going to have one called book reservation expired. And this is going to have book ID as one of the properties. And I'll put reservation ID there even though I don't need it, because why not, right? And let's go back to reservation expired. And let's put book reservation expired. And we're going to correlate this by book ID by default because we know we're going to use that by the book. By the book. Okay, I'm cracking myself up and getting slap happy. So we're going to have a book reservation expired event. And so then when book reservation expired, we are going to transition to, I get a comment, transition to available, because our reservation is expired. The book doesn't finalize because the book still exists. It just goes from being reserved back to being available. Okay. Did we capture any other data? No, we didn't. We just transitioned to reserved previously. I think I'm going to just put this down here just for fun. Funsies. I don't know why. Why not, right? Okay, reservation expired. So now when we get that event, now we have to produce that event from the reservation state machine. We are going to, just like, we're just going to go steal some code because it's easier to cut and paste than to create from scratch. We're going to create the book reservation expired. Do we want to necessarily say that it was expired? We can always rename it later because we don't necessarily care that it expired. We just don't want it reserved. We can just say canceled or whatever. Actually, let's just do that. Book reservation canceled. We don't care how it got there. We're just going to get it there, which means that I'm going to have to go change the name in here because I called it reservation expired. That's okay. Easy change. That way we have the consistency. The only thing we care about is the reservation ID and the book ID. The book ID we're going to get from the instance. We don't care about a timestamp, although we should, but that's okay. We have a sent time on the message in headers if we need it. Okay, so we have the reservation ID, book ID. Great, we're done. That should free up that, that instance. So let's run this now. See if we actually get that output that we're expecting. Up a little more word wrap space. Receive book, book received. What did it receive? Okay, so we got the book reservation expired, which went back to the state machine. The saga used that instance. It published book reservation canceled, which was then used by the book state machine. The reservation was removed. The book state machine completed, and all of that ran. So now we're going to actually see if our assertions work the way we expect them to, because they've been misbehaving and it's kind of driving me nuts. So we know that the saga harness not exists is there. We want to check this again, which is just, is our saga back in available based on the book ID? Okay, so why it worked this time, I have no idea. It just didn't like it that I said it had to be in the reserved state. Really wonky. But yeah, now if we look, we know that it's going back in that state. We cancel the reservation. It's processing the cancellation. And the book harness exists back in available shows. Here we know that the book harness was available. Once we know the reservation exists, I'm really stumped about why we're not getting. Oh, it won't be unavailable now. Watch it be unavailable. Okay, so this is actually good because it should fail here. Let's stop this because I don't want this to run anymore. Okay, so we want the book to also be reserved. Okay, so now our tests are working. I don't know why they didn't before. Must have been something weird. So now we know that the book saga harness exists in the reserved state. So we know that the book is reserved and the reservation exists. We roll the clock forward and then we verify that the reservation no longer exists and the book itself is now back to available. So we've closed the loop on the scheduling. So we have a full end-to-end scheduling. We're scheduling the timeout where the timeout message expiration is being sent back to the reservation saga. The reservation is canceling, announcing that the book reservation was canceled for whatever reason. The user could have canceled it as well. That could be something we could put in the UI later on if we really wanted to, is just say, nope, I don't want that book anymore. The book doesn't care why the reservation was canceled. It just wants to go back to being available. So that gives us all that. Let's try to run all these tests together again. Let's see if we get them to pass or if it's going to just freak out on me. Hey, all the tests pass. Great. I like that when that happens. So I knew this would be a short one. I just didn't want to drag it into the last one because that would have gotten us to like almost an hour and a half in a single episode. And I'm trying to keep them bite-sized and focus on a particular piece of functionality. So I will get these uploaded to YouTube. Thanks for joining. It's been great having people on with questions and stuff. More of these will be coming, once it gets out there. But so far we've gone over just creating a state machine, creating another state machine that talks to it, some interaction, some scheduling, how to do all the unit testing, which is something I think is probably hard to figure out and I get the most questions on. So thanks for joining on these first 3 episodes. Hope you've enjoyed them. There'll be more to come soon as part of season 2. So thanks, take care, and catch you soon.